So for these first few pages, until we get to the Chapter 2 practice test, that's the main one we're going to focus on. But I would like to pull out a few of these to do with you together. So you can just write on the PDF. Remember, you can open it up in a new tab. The download thing will appear. Hit the download button and then open and edit it. Make sure you save it. Okay. So this one, we're not going to do a lot, but I do want to just pull out a few from in the sections before we jump to the practice test, okay? So everybody, let's take a look at 12 and 13. Okay? So on 12, it says, state the domain and range, and is it a function or not? And then hit open and edit. And then you got it. Okay, so for 12, domain. So for number 12, for your domain, you are just going to list the x's you see. If something repeats, you do not repeat it for domain. It is what it is, what it is, okay? So that's the domain. The range are the listing of the x's. If they repeat, you don't put them down more than once. It's just a listing of what's there. 12, because the 4s and the negative 4s repeated for the x's only, it is not a function. "13, every single one of the x's are different. I don't care if the y's repeat. Who cares? All we care about is the x's. This one is a function. So that's all we're doing for that section. We're not doing 14 and 15. We're not doing domain and range for 13. Just whatever I do, you do. If I skip it, you skip it. Okay? So any questions about the domain and range of a discrete little set of points like that? Any questions about that? Are we good? Okay. Now, let's talk about plugging into a function. Now, this one, they gave us enough room to kind of just write right in that box. I want to do a few of these. So let's start with plugging in a positive. Now, remember, wherever the original x sits, you are going to take it out and input the new thing. So if I plug in 6, I'm going to do 4 times 6 squared plus 5 times 6 minus 9. Now, if you put a little parenthesis there, then you are more likely to follow order of operations, okay? So this is going to be 4 times 36 plus 5 times 6 minus 9. 4 times 36 is 144. 5 times 6 is 30. 144 plus 30 is 174. I just don't have room, so I'm going to write 174 minus 9, which is 165. Okay? So just take out your value, your x, replace it with a value. Now be careful when you replace with a negative. You still do. Look at the 16 compared to 17. You still do the same thing. Here is where my x's were sitting. I replace them with, in this case, 6, in this case, negative 2. The problem with plugging in a negative is when you plug in a negative, you have to be very concerned about what is happening. The square only applies to the thing in the parentheses. So negative 2 times negative 2 is 4. So this is going to be 4 times 4. This is still 5 times negative 2. I'll just leave that alone for the moment. Now, this is going to be 16 minus 10 minus 9. And you can do that from left to right at this point. 16 minus 10 is 6. 6 minus 9 is negative 3. Now, I'm not going to do 19, but I would like to do 18. We're going to do the exact same thing, except now we're replacing x's with 3y. So look at how you can write it. So it's 4 times 3y squared plus 5 times 3y minus 9. Okay? Now, let's go down the list order of operations. When we have an expression in there, we have a little bit more things to worry about. 3y squared means 3y times 3y. Multiply each piece by itself. 3 times 3, you're squaring the 3. Y times y, you're squaring the y. So this is going to be 4 times 9y squared plus 5 times 3y minus 9. And since I'm not doing the bottom one, I'm just going to go under it. Now, to multiply 4 times 9y squared, you just multiply those front constants, those coefficients. The y squared just stays there, so that's 36y squared plus 15y minus 9. Now, I would just take a second and glance over your problem at this point. There's nothing I can do because all of those terms are different. One's a y squared, one's a y, and one is a constant. They're just what they are. And so as far as you go, I plugged in 3y. I simplified as far as I can go. That is my answer. I'm done. Does that make sense? How we stop there. So if you go back and look at sections 2.1, section 2.1, that's where you would find if any of those things confuse you, where you could go back and look at notes or, kind of repeat that. Any questions about 2.1, I'm sorry. Any questions about 12, 13, 16 through 18? Any of those? Make sense? Okay. Now the next sections are 2.2. And so they say them right over here in the corner. So, as a good strategy, maybe as we're talking these through, maybe you only got confused on the 2.3 stuff. So those are the notes you want to go back and explore again, okay? So 2.2 are the next two little sections. Let's talk about what we saw in 2.2. There it's asking whether or not it is linear and yes or no, okay? And then I'm not going to worry about this part because we're going to do that later about graphing it. So you can just cross that out. We don't need that. Okay, we're not going to graph it at this time. Okay, so 20 is no. Because of the fact it's got this square on there, that square messes it up. 21, yes. Think about that as standard form, ax plus by equals c. So that's a yes. 22 is a yes. It doesn't look like a yes, but we could write it as y equals 0x minus 7. So isn't that in slope-intercept form? So there are two main forms of linear functions. Ax plus by equals c. Y equals mx plus b. Those are the main types. There are graphs that are linear that are not in that type, but they're just vertical lines. X equals a number. Those aren't functions. So this one's a no. Can't have any powers. We got a power. I see a power right there. So those two are not linear. That's a circle if you really wanted to know that. 20 is a parabola and 23 is a circle and not a line. Okay? So that's just kind of recognizing a linear function. So that's 2.2. And then 2.2 here, 24 through 29. We're not going to do many of those. But it says to write them in standard form. So I just want to practice that a little bit. So let's do, from here, let's do 24, and 26, and 28. We'll do those even ones, okay? So let's look at the instructions. It says, write each equation in standard form where a, b, and c are integers whose greatest common factor is 1. So we're just going to do those those three right there, okay? So let me remind you what standard form is. It's ax plus by equals c. Now, On the quiz, which please remind me, I need to get back to you. On the quiz, you guys kind of got it right, but you just didn't reduce it quite the way you wanted. So I didn't take off full credit, but I took off a point or something. So I want to show you what I mean by that. So let's start with 24. You want to rearrange so that your x and y are on one side and your numbers on the other. So we just have to do a little flip-flopping. So we want to move this to the other side, and we do that by subtracting 7x to the other side. Now, when we do that, we get negative 7x plus y equals 15. Now, it says to write it so that they have a common factor of 1. But another rule is we want a has to be positive. So on the test, or on the quiz, the last quiz, some of you left your x negative. But we switch it very easily by just switching the sign of everything. Multiply through by negative 1. So this becomes a positive 7, a negative y, and a negative 15. So that is the correct standard form. There's nothing that divides into 7, 1, and 15. The front x is positive. So there you go. That is 24. Now, another thing they mention up in the instructions is that our coefficients have to be integers. So 26 is in the right order, but they're not integers. So all you got to do, it's kind of a neat little trick. All you have to do is multiply through by the common denominator. The common denominator for 3 and 4 is 12. So you just got to multiply through by 12. So it's actually a really quick fix for these. Now to multiply that fraction by that whole number, just multiply the tops and divide by the bottom. So for 2/3 times 12, so this multiplication, just do 2 times 12 divided by 3. Well, 2 times 12 is 24, divided by 3 is 8. So that would be 8x. Do it again. Multiply the tops. 3 times 12 is 36, divided by 4 is 9. So that's minus 9y. And then 6 times 12 is 72. Now, if you take a look, there is nothing that divides equally into 8, 9, and 72. They're all very relatable numbers, but they're not something, only thing that divides into 8 are factors of 2. Only thing that divides into 9 are factors of 3. So we don't have to reduce it per se. Okay? But the last one, the reason I wanted to do 28 is because we do have a little bit of a reducing to do. So my x is on the left. That's good. But my y isn't. So let's add 12y to the other side. So we're almost done. And this is very much on the quiz where you stopped. You moved the 12y to the other side. You got it here, but here's what you forgot. What's the number that divides into all those things? 2. So if you get to this point, you're not done until you have divided by 2. So let's go ahead and divide everything through by 2. That means the greatest common factor is 1, not 2. So you got to divide it, okay? When we do that, we get 3x. Can't you divide it by 3? Oh, so we can divide by 6. Okay, so if you were a dork like me and you saw 2, if you saw 2, then you'd probably look at it again and go, oh, shoot, I could have done 3. So you can do it in phases. It's just going to take you more time. So let's be more efficient. Thank you so much for helping me with that. Let's instead, so we do it in one step instead of the million of I was going to do. Thank you. Let's divide by 6. Okay, so we get 1x plus 2y equals 8. And now if you check, there's nothing that divides evenly into 1 and 2 and 8. So that would be in the correct form. So just a few notes on that, some of the things I saw from the quiz. Okay, everybody good with that? Okay. So that is what you need to know from 2-2. Everyone good from that for that sections? Section 2-1 and 2-2. Everybody good? Okay, let's go to 2-3. 2-3 is just this little one. It says determine the slope. I'm just going to do one of them. We'll just do the top one here. The slope equation you need is y2 minus y1 over x2 minus x1. So you will need to know that formula on the test on Friday. So let's label our points. It doesn't really matter which one you choose as x1, y1, and x2, y2. Doesn't matter. You decide how you do that, okay? But let's plop that into the formula. So we're going to get 7 minus a -3. If you want to jump right to +3, that's fine. Otherwise, you have to write minus a -3. If you know minusing a negative is the same as adding a positive, and you change it to a +3, that's the most efficient way to do it. And then x2 minus x1. And then just add up the top, add up the bottom. And then always ask yourself, can I reduce that at all? 10 and 12 are both divisible by 2. So just divide the top by 2, divide the bottom by 2, and leave your slope in fraction form. Decimals are not helpful when it comes to slope. Fractions are important, okay? Everybody good with the slope equation? We good? Okay. Now let's jump to section 2-4, which are kind of the next two little blocks. 2-4, it says to write an equation in slope-intercept form that satisfies each condition. So you might recall, and I had it up on the board for a while, there are 3 steps. Step 1 is to find the slope. Now, sometimes they're nice and they give it to you. They say the slope is 7, and you use a slope of 7. So sometimes it's a matter of just pulling it out of the problem. Sometimes you have to do a calculation. Second step, we want to use the formula y minus y1 equals m times the quantity of x minus x1. That's called the point slope formula. You can use that to find the equation of lines for most types of lines. And then the third step is you solve for y. Okay, so we're going to do those 3 steps. And we're going to probably do 33 and 35. 34, I'll discuss with you, but we'll probably just do that. So let's do 33. Now it says to write an equation of a line that has a slope of 3/4 and passes through -6,9. So the first step in 33 has been done for us. They told us the slope is 3/4. That's great, okay? So now we can move on to the second step for that one. We have a nice little formula. This is m, this is x1, y1. So if we know that formula by heart, then we can just plop the information into that formula. So we get y minus 9 equals our slope times the quantity of x minus our x sub 1. Now we're minusing a negative, so if you want to jump to the +6, that's probably the best bet. But both the slope formula and the slope-intercept formula, they're kind of derived from the same thing, so you always end up subtracting the x1 or y1. When you subtract it, change its sign. And then the third step, we've got to solve for y. So now that we have the formula ready, it's just getting y. And it's usually the same thing each time. Distribute. Leave the left side. So that's going to be 3/4 x. Do the same trick we did before. 6 times 3 is 18. 18 is not divisible by 4. So I'm going to, for the moment, just write 18 over 4. Okay? Because I don't know what that is. Now, 18 over 4 does reduce down. So we can reduce that. They're both divisible by 2. So 18 over 4 is the same as 9 over 2. If you want to put 4.5 when it's a nice decimal like that, you can. Doesn't hurt my feelings. You're welcome to. All we got to do now at this point is add 9 to both sides. Now, if you want to keep it fractions, that's fine. If you want to make it 4.5 and add, you can. I don't care. But 9 is 18 halves. 18 plus 9 is 27. That would be 27 halves. If you wrote it as a decimal, it would be 13.5, and that's okay too. So if either 27 halves or 13.5 is correct. Okay? Does that make sense how that worked? For time's sake, we're not going to do 35. I just want to talk about 34 and 35. 34, they gave you the slope. The x-intercept is 3 halves. They actually gave you the point, 3 halves, 0. So if you write that as the point, then you could proceed with the whole thing. 35, you would have to find the slope, then pick one of the points to use in the formula. Okay? So everybody understand how I did 33. 3 steps. Find the slope, use the point slope equation, and then solve for y. Okay. Now, 37 through 40, I want to do one that's parallel and one that's perpendicular. So let's do 37 and 39. Okay, let's start with 37. It says we want to write an equation in slope-intercept form for a line that passes through 1, 2 that is parallel. What do we know about lines that are parallel? Same slope. So we know, in a way, they've just said, hey, the slope you're using is -3. Because remember, we're still going to do the 3 steps. So step number 1, find our slope. We found it. It's -3. Step number 2, we're going to use the equation y minus y1 equals m times x minus x1. See that we keep writing those equations. You have to know those by heart. So let's take our x1 and our y1, 1, 2, our slope of -3. Let's plop it in. So we get y minus 2 equals -3 times x minus 1. And the third step is to solve it for y. To solve for y, it's pretty much the same procedure every time. Distribute. Move this. Distribute. Move this. It's pretty much will be that setup. If you distribute, you get y minus 2 equals -3x plus 3. If you add 2, because we have a minus 2 on the left, it's going to become a plus 2 on the right. Our equation is -3x plus 5. Okay? Now, I'm not going to waste time and do all of 39, but I do want to talk about what you would do. Okay? The hardest part about 39 is finding the slope, because it says we are perpendicular. Well, you know what? Let's do 40. Again, we're not going to do the whole thing, but let's do a little bit of 40. The slope they are showing is -2/3. What is the slope we're going to be using? And how did you get that? Can you tell us? Yeah, we flip it and change the sign, so we take away the negative. The slope we're using for 40, we flip it and change the sign. So it's the flip and the opposite. So flip and change sign, what you want to do every time. Okay? Everybody good with the solve or find the equation of the line? Okay. Now, if we could, we're skipping that one. Those are so fuzzy. Let's just skip that. You know what? Let's jump now, if we could, to the very, very last page. See where it says Chapter 2 test? That's the kind of the Chapter 2 test review. We're going to do another one tomorrow because it's an entire chapter. And it's since we started Chapter 2. I don't remember when we did that, but it's been a few weeks now. So I wanted to make sure that we have 2 days to review this stuff. So we'll review one more time tomorrow, but I just want to jump down to look at some of the ones we haven't done yet, okay? So we did these, we did plug it into the function, we found slope, we wrote some equations. We're not going to do the scatter plotty ones. So let's just focus then on graphing, okay? So we're going to focus on 7 through 18 for the rest of the time that we have for class, okay? And I'll give you enough time to save it and upload it, okay? So let's talk about 7 through 18. Now we're not going to graph all of these, just graph some of them in what we have time for. Let's start out with 18. Now all I want you to do is pick a spot on your paper, make a little XY axis. I don't expect it to be lovely and perfect. Just do your best, because I know you're writing on tablets, some of you for the first times doing it. Let's go 4 in all directions. Okay, so I got my graph paper ready. I'm gonna, my y-intercept is -4. My slope is 3/5. So remember how you would graph a line without plugging in points. Now, there's nothing wrong with taking, if you forget how to do it, and you plug in +1 and -1 and 0 and go for the graph. Go for it. It doesn't hurt anybody, okay? But what we can do, a little shortcut method, is we can start at -4, put your dot, count up 3 over 5. So I guess I should go 5 in all directions, or just guesstimate. And then because lines only require us to have 2 points, then we can connect it and just really kind of stretch it as big as your graph paper allows. If I'm like below an axis, I like to try to go through it. But that's all we need for that, okay? So I hope if something is in slope-intercept form that you know how to graph it pretty nicely. I want to now go to 8. Okay, so that is not in slope-intercept form, is it? It's kind of like a wonky standard form one. In a standard form one, I like to do a very specific thing. So let's take and move that 2 to the other side by subtracting 2. Let's put it in standard form, because I want to show you how to graph with standard form very nicely. The intercepts are a very nice tool when graphing something, a linear equation in standard form, okay? So the x-intercept, you let y equal 0. The y-intercept, you let x equal 0. So all I'm going to do is plug those numbers in and see what I get. Make a table, 2 points, connect them, there you go. Okay, if I let y equal 0, this is going to become 0. I get 4x equals -2. So if I want to solve for x, I just divide off the 4. So that's 2/4. Now, do we write something as -2/4? What's a better way to write it? How could we reduce it? Yeah, divide that by 2. Make it -1/2. Okay. Now let's do the other one. This time we're going to let x equal 0. So this piece is going to become 0. So that would leave us with -y equals -2, because our x is now 0. So anything touching it becomes 0. Okay? And then we just have to divide off the negative. If we divide each side by -1, we get that y is equal to 2. And then what's great now, again, I'll just go kind of, this time I'll go 2 in every direction. We hit the x-axis at -1/2. We hit the y-axis at 2, and you make your line. Again, make it the best you can. Okay? So that's what we're going to do from 8 to 18. What time does this bell ring? 20? 32, thank you. Okay. Now I would like to do some inequalities. So if we could, let's jump to 7. Any questions about 8 or 18 before I move on? Okay, let's jump to 7. For 7, unfortunately, we have to solve for y. Now, the y is by itself, but we need to divide by 3. So let's divide every single piece by 3. Now, unfortunately, the left side isn't very nicely divisible by 3. So we get negative 2/3 x plus 5/3 is less than or equal to y. Now, when we did inequalities, I told you, you want to make sure that you have solved for the actual y value. So we need the y to go on the left side. So when we turn it, turn the inequality with it. Okay? So now we're ready to go. Let's talk about, do we do a solid or a dashed line? If it's an equal to, I need a solid line. If it's greater than, I'm going to shade above it. So before I even move on, you kind of have to make that determination. Am I making my graph, my line, a solid line or a dashed line? Solid. Bless you. Solid line. And then am I shading above or below? This is greater than? It's above. We want those y's getting higher than it, above it. The y's get larger, greater as I go above it. So now let's set up our little graph paper. I'm going to kind of try to go like 4 or 5 up and down. We'll see. See how much room I need. Okay. 5/3. If you were to put that in a calculator, 5/3 is about 1.7, something like that. So go to about 1.7 and start about there on your y-axis. Now you just have to guesstimate. I know that. Just do your best, okay? We're going to count down 2 from there and over 3. So you want to kind of stay at that same height. So it's about right there. And then I make my solid line. And I want to shade everything that is above that line. And that's how we would do that. Does that make sense? How that worked? Look good? Okay. Now, if we look at graph number 9, if it's only an x, it is a vertical line at x equals -4. So that's all number 9 is. So x equals a number is vertical. Well, let's look at 11. Y equals a number is horizontal. We still think of the fact that we want a horizontal line at 10 that's solid. We want less than the line, so we're going to shade under. So that's 11. So this is 7, this is 9, this is 11. Are you guys good with those ones? Does that make sense? Okay, for 15, could we change this to an equal to? Just because we had done 2,6 about absolute values, and I just want to make sure we have an absolute value to graph, okay? Now, and when we do 15, what I had said were 3 steps when we do an absolute value. We're going to take the inside. In this case, our inside is x minus 1. We're going to set x minus 1 equal to 0 to find our vertex. So in this case, our vertex is at 1. So that's our first step. Our second step for 15 is to make a table. Remember, we make a table with the vertex on it, one below it, and one above it. And we're just going to plug those numbers in and see what happens, okay? If I plug in 0, I get 4 times the absolute value of negative 1. What is the absolute value of negative 1? What is the absolute value of negative 1? 1, right? It just takes off that negative. And so 4 times 1 is 4. Now let's plug in 1. We get 4 times the absolute value of 0. What's the absolute value of 0? 0. So 4 times that is still 0. Now what should we know about 2? What should we get if we're right on the chart? The answer's sitting there. What should our answer be? It should be 4. So let's put 4 down, but let's just do the math real quick and check that we really do get 4. If you plug in 2, you get 4 times the absolute value of 1. Well, the absolute value of 1 is 1. The absolute value doesn't do anything to a positive number, and so it's just 4 times 1, or 4. These match. That's a really good indication I did it right. Okay? So now let's go over to our graph paper and plot those points and make a V. Remember, the shape of these is a V. So you set the inside equal to 0. You make a chart. Plug them in. Okay. So at 0, we are at 4. At 1, we are at 0. At 2, we're also at 4. Did we make a V shape? Yes. Okay. And so now you just connect your V. Are you okay?
Yeah.
Okay. So, some things to think about. The test is Friday. If some of these things that we have talked about now confused you, you know what sections they're from. The graphing, it's a little all over the place, but you have taken notes now for every section. I have posted a video for every section. I'll post this video. I'll post a test review video. So you'll have things to study. You are getting up to a level of math that you actually might have to look something over before you take your test. So just so you know, it's a good idea to review and study, okay? So make sure you save this. Hit Save As. You can download to your device. Save As. It's a good idea to put it in your drive. Remember, making a math folder with all your math stuff in it is a good idea. Make sure that you've turned this in. You should only be doing the ones I did along with you now. And then when we're getting close to the end, put your stylus away, put your Chromebooks back. Remember, hinges down with the little white number showing. Okay? And make sure it's charging.